Good morning, guys. Happy Friday. Hope everybody had a good week. Um, so let's go ahead and get started. So I am not 100% sure. Well, before I get started, actually, you should have completed the warm up, the notes. So that means that you should have watched last time's video and the exit ticket as well. You should have completed that because all of that is going to be for a grade, okay? And also, don't forget that you had 28 Matthias due today. However, I will be extending the deadline to by Monday, 7 a.m. So you have the weekend to work on that. Um, and yeah, okay, that's all the announcements I had. All right, so for this lesson, I'm not 100% sure what page we left off on. I think it's like 500 and something, or it might be 600. So you're gonna have to flip through these pages, okay? Look for the title that says "Double the Fun Using Graphing to." Whoops, sorry about that. Using graphing to solve systems of equations, um, and and the number 2 on the top, right? Um, so yeah, with that being said, hopefully you found it. We're not gonna be doing this warm up. We're starting to do the warm-ups on Schoology because we're going to be doing start practice questions starting from now on for the warm-ups, okay? So you should have picked 4 questions last time, and then today you're going to have to pick another 4 different questions. So the Google Doc is gonna have a lot of questions, and you don't have to do every single question because it's too many. So what we're doing is that you do 4 every time. So you should have done a 4 last time, and then today you need to pick 4 different questions and do those 4. So you should have a total of 8 questions. Okay, please make sure that you do not do the same questions. Okay. All right. With that being said, hopefully you did the warm up, and let's go ahead and get started. All right, we're going to skip through a lot here. It's pretty short lesson, so we're not going to do this page. All right, this one we will be doing. So it says analyzing the graph of an equation in standard form. Consider the goal of an athletic association described in the previous activity. So we didn't do the previous activity, but it's okay. It's okay because it gives us a number, so we don't really need to do it. It says let S represent the number of student tickets sold. So S is the student tickets, and let A represent the number of adult tickets sold. Written in standard form, the equation that represents the situation is 5S plus 10A equal 3,000. Let me go ahead and erase that. All right. I'm gonna go ahead and replace the S and A with X and Y just because I know a lot of you guys are more familiar with that. And also the graph right below this, that graph is labeled as X and Y. So let's just do that. X and Y. And then this is gonna be 5X plus 10Y equal 3,000. All right. So it says, let me zoom in a little bit. One efficient way to graph a linear function in standard form is to use x and y intercepts. Now, you guys are very familiar with how to graph a slope intercept form, and now we're going to be starting practicing how to graph standard form. It is a little bit of more work, but it's nothing too complicated, and it's actually pretty easy. So it says you can calculate the x-intercept by substituting y equals 0 and solving for x. You can calculate the y-intercept by substituting x equals 0 and solving for y. So let's go ahead and do that. So we have 5x, or I'm not going to rewrite it. We're going to do this one right here, this equation right here, right? First, let's find the x-intercept. That means that y equals 0. So we have 5x plus 10 parentheses 0 equal 3,000. So 5x plus, actually, let's not do that because 10 times 0 is just 0. So do I really have to write down the 0? No, I don't. Okay, but, okay, I'll do it this one time just to show y'all. So 5x plus 0 equals 3,000. What's 5x plus 0? Well, that's just 5x, right? So I could have just done this instead of doing this. All right, now I solve for x. So I need to get the x by itself. What is in the way of that x being by itself? The 5. So I need to move the 5. How do I move the 5? Well, I had to figure out what operation is it. This is multiplication. Why do I know that? Because there is nothing in between the 5 and the x. Even though there is not a multiplying symbol, whenever you have two terms that are next to each other like that with nothing in between them, that is multiplying. All right, so to undo that, I divide by the number next to the variable. So I divide by 5 on both sides, and I get that 3,000 divided by 5 is 600. And then this is an ordered pair, so this is actually going to be 600 comma 0, because remember, the y is 0 for the x-intercept. Uh-oh, why is it not letting me scroll down? Oh my goodness. Okay, there we go. So let's go ahead and plot that. So this is increasing by 100 every time. So this is 500 right here, and then 600 is going to be right here. All right, let's go ahead and do the y-intercept now. Oh my goodness, why is this thing letting me scroll? It's not letting me scroll. So I had 5x plus 10y. Okay, so right here, I had 5x plus 10y equal 3,000 again. And now I'm going to rewrite it again. 5x plus 10y equal 3,000. And now I'm finding the y-intercept. So for y-intercept, x equals 0. So let's go ahead and substitute 0 for, or x for 0. So instead of 5x, I'm going to have 5 parentheses 0 plus 10y equal 3,000. So I should have 10y equal 3,000. Because I don't have to rewrite the 0, right? And we're not going to do that again because I already explained it on the last example. All right, so now we solve for y. What is the thing that I have to get rid of? The 10, right? So what operation is this? Again, multiplying. So I divide by 10 because I do the opposite of multiplying. And this gives me 300. So then this is going to be 0, comma 300 because x was 0, and then this is our y. And that's going to be right here. So then you just go ahead and connect the two points, and that's your equation. Let me zoom out a little bit for this. Okay, what determine the domain and range of each. So domain is x, range is y. So to find the domain, since domain is x, think about the x-axis is going from left to right. So that's how we read the domain, okay? Usually if I was in person, I would have a piece of paper and I would tell you to start from the left side until you touch, and slide the paper inward until you touch the first thing on the graph. So if I were to do that, this would be the first thing that I touch, right? So the first thing that I touch is this arrow right here. Since the arrow is on the left side, this means that it's going to be all the negative numbers. And arrow means it goes on forever. So what do we call that? Infinity. Then I go to the right side. So the right side is going to be over here. The first thing that I touch is the arrow on the right side. So the right side is all of the positive numbers, right? So this is going to be positive infinity. Now, what do we call it whenever it's from negative infinity to positive infinity? We call that all real numbers. Okay, now we're going to do the same thing for range. So for range, let me go ahead and change the color. For range is y. And think about the y-axis. It goes top to bottom, bottom to top. Hold on just a second, guys. Sorry. Okay, so for range is the y-axis. So we start at the bottom. The bottom is going to be this right here, right? Whoops, I didn't mean to put the arrow. the bottom is going to be right here. So we touch this bottom arrow first. Now, since it's at the bottom and it's going down, that means that's all the negative numbers, so negative infinity. And then if I go in from the top with my imaginary piece of paper, the top is the arrow at the top right here, and it's going up. That means that the numbers are increasing, so this is positive infinity. Again, this is going to be all real numbers. All right, so we call this, yeah, our real numbers. A little hint, if you guys remember from the very beginning of the school year, we talked about this. Linear functions are always going to have all real numbers for the domain and range, okay? That's always going to be like that. I just wanted to demonstrate for you guys what that looks like, but just remember that is always going to be all real numbers if it's a linear function. All right, the function model in the real world situation. So let's start with the domain. The domain was X. So the domain, we look right here, it was at 600. So that means that it's going to be from 0 less than or equal to X less than or equal to 600. So it has to be between those two numbers, 0 and 600. All right, range. Range was 300. So it's going to be 0 less than or equal to Y less than or equal to 300. Okay. Sorry about that, guys. I had to take care of my dog real quick. All right, so then it says explain what intercept means in terms. Okay, we're not gonna do this. Usefully notes. We're also not gonna do this. Okay, this one we will be doing. So it says the athletic director of the Marshall High School Athletic Association says that 450 total tickets were sold to the home game. Write an equation that represents the situation. Let S represent the number of student tickets sold, and let A represent the number of adult tickets sold. Okay, so we don't know how many student tickets sold, and we don't know how many adult tickets were sold, right? So since we don't know that, we're not going to be using any numbers. We're going to be using those variables. So we have S plus A equal, but we do know that the total was 450, right? Another way to write this, if you want, to replace the X and the Y like that, you can do that. All right. So that's our linear equation. All right, it says the coordinate plane shown already contain a function that models the earnings from ticket sales. Use X and Y intercepts to graph the function modeling the total number of tickets sold on each coordinate plane. So let's go ahead and find the x-intercept first. So for the x-intercept, you have y equals 0. So for the x plus y equal 450 equation that we came up with, we're going to be replacing the y with 0. So if I have x plus 0 equal 450, x plus 0 is the same thing as just x, and then equal 450. What is this point? This is 450 comma 0. All right, and then now for the y-intercept, we have x equals 0. So we have 0 plus y equal 450. 0 plus y is just y equal 450, and then it's going to be 0 comma 450. So now let's go ahead and graph that. So we have 450 comma 0. This is going up by 100, so 450 is actually going to be right here in the middle, and then 450 over here is going to be up here, and then you just connect those two, and then same thing for over here. So 450 is going to be right here, and then up here, and then connect those two. I messed up a little bit, but yours will be prettier. Just use your ID. All right, so that's that. We're not going to be doing this page. Let me see. And All right, we are going to do this page. So it says Marcus and Philip are in the robotics club. They are both saving money to buy materials to build a new robot. Marcus opens a new bank account. He deposits $25 to that he won at a robotics competition. He also plans on depositing 10 a week that earns from tutoring. Philip decides he wants to save money as well. So he already has $40 saved for mowing lawns over the summer. He plans to also save $10 a week. Write equations to represent the amount of money Marcus saves and the amount of, okay. So Marcus, we said that he deposited $25. So he is starting with $25. That means that is my y-intercept, right? Then it says that he is depositing $10 a week. So even though it doesn't have the word each, this is kind of common sense. Like if he's depositing $10 a week, that means that he's doing that each week or every week, right? So that's going to be your slope. So I have y equals 10x plus 25. And then for Philip, is going to be y equals, he already saved $40, so he starts at 40. And he plans to save 10 a week, so it's going to be 10x. Use your equations to predict when Marcus and Philip will have the same amount of money saved. Are they ever going to have the same amount of money? Well, to do this mathematically, like you would graph it, put this on decimals, and you're going to see that you get two parallel lines, okay? Even if you didn't graph it, just from looking at the slopes here, the slopes are both 10x right here. So since they have the same slope, that means that they're perpendicular lines. And perpendicular lines do not ever intersect. Therefore, they are never going to have the same amount. So they will never have same amount because parallel lines have no solution. Okay, and that's it for that. All right, we're not going to do this bottom part. Let me see. We're not going to do this one. We're not going to do this one. Let's see. None of this. Wait, this one either. Sorry, guys. All right. So for this one, graph the linear system on the coordinate plane. So this one, do on decimals. You're going to graph the two equations that we came up with. Desmos. Oh, my God. Desmos. All right. Or TI 84. So you can do it either on your calculator or decimals, whatever you prefer. All right. So moving on. We're also not going to do this. Sorry, guys. I'm skipping through a lot. It's just that I'm trying to get through this lesson quickly. All right. And also, I want you guys to have that Matthew time to practice. So go to the very back over here. Okay, this is the important stuff that I need you to know. It says a system of equations may have one unique solution. So this is really important. These are three different types of solutions that they can have. Okay, so you get one unique solution, no solution, or infinite solutions. So one unique solution is whenever they intersect, and that's one solution. Okay, so one solution. No solution is whenever you have parallel lines. They're never going to touch. They're never going to intersect. So no solution. And then infinite solutions is whenever you have the same line overlapping. So we have one line and then we have another line on top of that. Okay. All right, so y-intercepts can be the same or different number of solutions. So if they have the y-intercepts that are the same or different, is going to have one solution and is going to say lines intersect. So it's like the first picture I drew. Y-intercepts are the same. If the y-intercepts are the same, that means that they have infinite solutions. Infinite solutions. And then that means that is the same line. And then inconsistent systems, y-intercepts are different. That means that they have 0 solutions and they're parallel. All right, guys. Well, that's pretty much it. I hope this video helped. Hope you guys have a great weekend. Please don't forget to do your Mathia, do your exit ticket. Make sure you did that warm up. So yeah, that's pretty much it. For the rest of the period, just do the exit ticket and work on Mathia because you need 28 Mathias. Hope y'all have a great rest of your day. Bye. See you guys next week.